So hello all, welcome to Gate Methods. Today in this lecture series of subject operating system, I'll be starting the unit memory management. So as we all know that it's a functionality of our operating system is to manage the memory in such a way that our process will run smoothly. So how a memory is managed? Suppose a process is residing in a secondary memory. You can say it as a hard disk, and it has to be swapped to the main memory. So how these things are managed in such an efficient manner so that our process will run smoothly. So in memory management can be done by using various methods. Okay, so memory management can be done using various methods. What are those methods? One is fixed partitioning and variable partitioning, or you can say dynamic partitioning. Fixed partitioning and dynamic partitioning. And fixed partitioning can be done in two ways, in which the partition size can be variable or it can be fixed. Okay, partition size can be fixed or it can be variable. And on coming up to dynamic partitioning, so in dynamic partitioning we have two concepts to be studied. One is contiguous and non-contiguous memory allocation. Okay, contiguous and non-contiguous memory allocation. Contiguous memory allocation. Okay, and in non-contiguous memory allocation we have various methods proposed, like paging, segmentation and all. So let's come on to the fixed partitioning. Okay, let me rub this on. So in a fixed partitioning, okay, so we have a main memory and one secondary memory. Okay, one secondary memory, and from secondary memory process has to be moved in. Suppose in the secondary memory we have processes, or when a process is in a secondary memory, we don't call it as a process, we call it as a program. Okay, when it is loaded into the main memory, then this process this program can be said as a process. Okay, this is the difference between the process and a program. So in a secondary memory we have, you can say, but these terms program and process are used interchangeably. This is the difference. Okay, so we have p1, p2 and p3, and lots of processes in a secondary memory. And what we do in fixed partitioning is that we divide our main memory into some fixed size partitions, okay. These are the fixed size partitions. There is the fixed partitioning can be implemented in two ways. One is fixed and variable. What are these fixed and variable? If we have partitions, if the partition size is fixed, let's say if the partition size is fixed to 2 KB, so we have 2 KB blocks, or you can say 2 KB partition size of 2 KBs. Okay, 2 KB. So what are the disadvantages, or what are the shortcomings in this method? Okay, or we can if the let's come on to the variable size fixed partitioning. So if the size of a partition is variable, let's say if we have the size of a partition as variable size of partitions, so we can have let's say 2 KB or 4 KB or 8 KB or 16 KB and 32 KB. Okay, so this is a implementation of fixed partitioning having variable length of partitions. So suppose a process of size 1 KB is to be loaded into the main memory. There is one process of size 1 KB is to be loaded into the main memory. So it will reside into this partition, let's say 1 KB. Okay, and we have another process of 3 KB. We have one more process of 3 KB. Let's name it as P1 and P2. P2 size is 3 KB. Okay, 3 KB. So it will be residing in this 4 KB block, or you can say partition. Let me use a different color. Okay, so 3 KB process will be occupying this space or this partition, and we have, suppose we have process P3 of size 7 KB. Okay, of size 7 KB. So a 7 KB process will occupy this partition 7 KB. Okay, 7 KB, and we have one more process of size, let's say 15 KB. Okay, P4 size is 15 KB, and we have one more process of size 31 KB. Okay, P5 having size 31 KB. So by using the best fit algorithm, I'll explain what is best fit, what is worst fit, and all. So I am allocating the process by using the best fit. Okay, so what is the best fit? It will the process will occupy the space in the memory which is just nearest to the process size. Okay, so that 15 KB process 15 KB process will occupy this much space of 15 KB, and a 31 KB process will be residing there. 31 KB. Okay, it's 31 KB, and leaving the 1 KB spaces. Okay, so there is a limitation that we cannot put two process in one partition or in one block. We can't put two processes. Okay, only one process will occupy one block of a memory. Okay, these are blocks, or you can say partition. So only one process will occupy one partition. We cannot put another 1 KB process in this partition. Okay, only one process will occupy this partition. So we have 1 KB of free space in this, and 1 KB of free space in this, 1 KB of free space in this, 1 KB of free space in this block, and 1 KB of free space in this block. So if we have and the memory is full. Okay, and if we have another 1 KB process, let's say P6 has to be loaded into the memory. P6 of size 1 KB has to be loaded into the memory, and we have available space of 1 KB, or let's say 1 2 3 4 5 KB space in the memory, and we cannot accommodate 1 KB process. Okay, we cannot accommodate 1 KB process. So it's a kind of internal fragmentation. Okay, what is internal fragmentation? We have 1 KB of free space in this block. Okay, and we can't put this 1 KB process into this block, and we have 1 KB of free space in this. So what are the disadvantages of using the fixed size partitioning? What are the disadvantages? The first disadvantage is internal fragmentation. Fragmentation is nothing but it's a kind of memory wastage. Okay, we face by using fixed partitioning, we face internal fragmentation, face internal fragmentation, And what is internal fragmentation? I've just told you that we have 1 KB of available space in this block, but we can't accommodate another process of same size into that. Okay, and we have we have external fragmentation. External fragmentation, suppose a process of size 5 KB is there. A process of size 5 KB is there. 5 KB is there. Process of size 5 KB is there, which we have to accommodate in the main memory from the secondary memory. So there is a total available space of 5 KB here. Okay, 1 2 3 4 5 5 KB space is there, but we can't accommodate the 5 KB process into the main memory. Okay, so this is called external fragmentation. External fragmentation. External fragmentation. And what are the other limitations? What are the third disadvantage is it can accommodate only up to a process size is fixed. You can say, let me explain this. If a process of 64 KB process has to be accommodated into the memory, but the largest partition that we have is 32 KB, so we can't accommodate the process of size 64 KBs of process 64 KB. Okay, we can't accommodate into the main memory. Okay, so it's a disadvantage that we have limit on process size. Okay, if the size of a process exceeded that limit, so we can't accommodate those process into the main memory. Limit on size of process. Limit on size of process. Okay, and the fourth disadvantage in using the fixed partitioning method, either it can be a variable size fixed partitioning or fixed size fixed partitioning, we have a limitation or disadvantage that it limits the degree of multiprogramming. It limits the degree of multiprogramming. Limits the degree of multiprogramming. Limits the degree of multiprogramming. Okay. It limits the degree of multiprogramming. How it can limit the degree of multiprogramming? So let's discuss what is multiprogramming. Okay, so it's a kind of a multiprogramming. It's a kind of a operating system that we have and that we are using. Okay, so in this it limits the degree of multiprogramming. Suppose what is multiprogramming? So at a given number of time, at any time, in the main memory, the number of process will tell about the degree of multiprogramming. Okay, so if we accommodate a 5 process up to a 5 process in our main memory, if we can accommodate up to a 5 process into our main memory, okay, so the degree of multiprogramming will be 5. Okay, if we accommodate 5 process at any time, there will be 5 process in our main memory, then our degree of multiprogramming will be 5. Okay, so we are dividing our main memory into some fixed size partition. So these fixed size partition will also have some number. Okay, suppose we have a main memory of 4 MB. Okay, and we are dividing our main memory into some fixed size partition, or you can say variable size partition. I am taking a fixed size partition because it will be easier for me to explain. We have a total 4 MB of main memory, and we divide our we partition that 4 MB of main memory into 4 KB size. Okay, so how many blocks will be there, how many partitions will be there? 1024 partition will be there. Okay, so the degree of at any time in the best case, the number of process which we can accommodate into the main memory will be 1024, because there are 1024 partitions. Okay, of size 4 KB, if we have a size of main memory as 4 MB. Okay, so the degree of multiprogramming will be 1024. The degree of multiprogramming will not exceed that number, will not exceed 1024, because we have 1024 partitions, and we cannot accommodate 2 process in one partition. Only one process will be there in a single partition. Okay, so it limits the degree of multiprogramming. So it has various disadvantages. I think I have discussed all the disadvantages that it's having, and let's come on to the dynamic partitioning. Okay, in dynamic partitioning, what is dynamic partitioning? What is dynamic partitioning? To the dynamic partitioning. So in this dynamic partitioning, we do not divide our main memory into some fixed size partition. Okay, we will not divide our main memory into some fixed size partition or variable partition. We do not partition in our main memory. Okay, we will not partition our main memory. And suppose it's our main memory, and some amount of space is acquired by the operating system code, OS code, and we have various processes in our secondary memory. Okay, various processes in our secondary memory which has to be accommodated, or which has to be executed by the CPU. So in order to execute it by the CPU, they have to be moved from secondary memory to the main memory. It's our secondary memory and it's our main memory. So we have various processes like P1, P2, P3, P4, and like this. So, and these processes are of variable size, 2 KB, 4 KB. I am taking process as 2 KB, 4 KB, but to explain you that. And in the in current scenario, the process are not of 2 KB or 4 KB. They are much bigger in size. Okay, they are in MBs. So what we do in this, we will not divide our main memory into some fixed size partition, so the process P1 will come first and acquire this amount of space, the amount of space equal to its size it will acquire in the main memory. Suppose the memory which is to be usable by the user starts from 100k and so 0 from 0 to 100k, the operating system code will be present into the main memory, so it has to be untouched by the user. Okay, and if someone tries, or some program tries to access that part from 0 to 100 kb, so it will lead to a trap. Okay, what is a trap, I will discuss it later. It's a kind of interrupt that we have. Okay, software interrupt. So the process will come and acquire the space into the main memory accordingly, and there is no partition. Okay, and there is no partition, and there will be no partition in this. Process will come and acquire the space P6 and P5. Okay, so do we have internal fragmentation in this, as we have in fixed size partitioning? We have in fixed size partitioning that we have internal fragmentation, that 1 kb of space, free space, will be of no use. So do we have same kind of condition in this in dynamic partitioning? So the answer is no, because we do not have internal fragmentation. Why we will have internal fragmentation? We will not be having internal fragmentation. Okay, because we are allocating the space dynamically. One by one the process are coming from the secondary memory, they will be acquiring the space into the main memory, and will be arranged like this, and there will be no internal fragmentation. Okay, because we are not dividing the main memory into some fixed size as we have divided into this. So we have divided our memory into some fixed size partition, and only one process will can be accommodated into a partition. So suppose we have 2 kb size of partition, and the process size is 1 kb, and 1 kb will be wasted. 1 kb amount, that much amount of memory will be wasted. So in this dynamic partitioning, this condition will not be there, so internal fragmentation will not be there. Okay, it's an advantage, or you can say it's an advantage, that we do not have internal fragmentation, and we do not need to divide our main memory into some fixed size partition, due to which internal fragmentation will not be there. And do we have external fragmentation in this? The answer is yes. How can we have internal fragmentation? Suppose a process P2, let's say process P2 is of size 5 kb. Okay, and process P6, let's say, is of size let's say 8 kb. Okay, 8 kb, and the process P2 and P6, due to some condition, they are moved out from the main memory. P2 and P6, due to some condition, either they are completely executed, or a process of higher priority is there, which has to be given space into the main memory. A process which is having higher priority than P2 and P6 is come, so we have to accommodate that process because it's of higher priority. So in order to accommodate we have to move the process P2 and P6, low priority processes, or you can consider a condition where P2 and P6 are moved because they are completely executed by the processor, so they have to be moved. Either any of the condition will be there, so they have to be moved out from the main memory. So they will lead to a hole, you can say they will lead to a memory hole, or you can say a free space they will. So how much amount of memory is freed, so it's 5 KB memory is freed here, and 8 KB memory is freed here. Okay, 8 KB memory is freed here. So suppose that high priority process, or you can say the next process which is to be accommodated, is of size 10 KB. Let's say P7 is of size 10 KB. 10 KB process is to be accommodated into the main memory in place of P2 and P6. So how much the total amount of free space that we have? 5 plus 8 is equal to 13 KB of free space we have in our main memory, but we can't accommodate this P7 into our main memory. Okay, so it's a kind of it's not a kind of, it's a external fragmentation. Okay, so we have external fragmentation in dynamic partitioning. We have external fragmentation in dynamic partitioning method we have, but we do not have internal fragmentation. Internal fragmentation condition is removed by using dynamic partitioning. So we have external fragmentation in this. So what is external fragmentation? I have just explained. Its external fragmentation is a condition in which if we are having that much amount of free space in our main memory and a process size of less than that free space is there, and we have to accommodate that process, but we can't accommodate. Okay, so this external fragmentation if we want to accommodate the process of process P7 into our main memory, if we are using dynamic partitioning, so we can accommodate it in a non-contiguous manner. Okay, non-contiguous manner means we have to divide our process now. Okay, so let's say we have divided a process into two parts, that P7 process into two parts. Okay, so 5 KB and 5 KB. So P7 1 of size 5 KB will be placed here, and P7 2 of size 5 KB will be placed here. Okay, so we have accommodated our process completely into the main memory, but in not in a contiguous manner. Okay, we have divided the process. So if we have used the non-contiguous memory allocation. Okay, the concept of non-contiguous memory allocation, we have two methods in this. One is paging and another one is segmentation. Okay, what if we want to allocate the space into our main memory in a dynamic partitioning method without using the non-contiguous allocation? What is non-contiguous allocation? I have just explained you that in that we have to accommodate the process in a non-contiguous manner. We have to divide the process. Some part of the process or program will be at one place, and some part of that will be at another place. Okay, so it's a non-contiguous manner. So what if we have to accommodate our process in a contiguous manner? Let me write the condition. Okay, what if what if we want to accommodate, what if we want to accommodate a process in a contiguous manner, contiguous manner, contiguous manner in dynamic partitioning, dynamic partitioning, dynamic partitioning. What if we want to accommodate a process in a contiguous manner, in dynamic partitioning, by using the dynamic partitioning, okay, without using the concept of non-contiguous methods that were paging and segmentation and all. So what we can do, is it possible to allocate a 10 KB process, a process size of 10 KB into our main memory? Okay, yes, it is possible. It is possible by using the method of compaction. Okay, by using the method of compaction. What is compaction? A compaction is a method in which we move processes, processes from one part to another part in a memory, from one place to another place in a memory, in order to accumulate the amount of free space into our main memory. Okay, what I mean to say is, what we will be doing here in a compaction method, we will be moving the process P3, P4 and P5, shifting upward or downward, or in some manner we will be pushing. Okay, so here a process, we will be moving a process P3, process P3 and P4 and P5. Okay, we are pushing the process here P3, P4 and P5. So we have the amount of free space is accumulated at the amount of free space will be accumulated in somewhere. Okay, so we have the total of 13 KB of free space here. Okay, by using the concept of compaction, we have 13 KB of free space accumulated at one part of a memory. So now we can easily accommodate the process size of 10 KB, that is P7, into our main memory. Now we can easily accommodate. Okay, what we have done, we have moved the process into one part of a memory, and we have accumulated the amount of free space in the main memory. Okay, so we can use this method compaction. Okay, so how can we implement this method? By copying the data bit by bit into a memory. Okay, by copying the data bit by bit into a memory. Suppose previously process P3 was there something here. Okay, so we have moved the process P3 from here to here. From here to here we have moved the process P3, and we have also shifted the process P4. How can we do that? So we can do by using the process of copying data bit by bit. Okay, so by using this method is by using this method we can allocate in a contiguous manner, but this method is also having a disadvantage. What is that? So in in the time of copying or shifting the process, in that time we can't perform any operation. Okay, we can't perform any operation. Meanwhile we can't perform any operation. Okay, because our processor is busy in shifting the process in a memory. Okay, so our CPU time is precious. Our CPU, or say processor time, is precious, and processor will be busy in shifting the process. Okay, in order okay, in place of executing a process, it will be busy in shifting the process in a main memory. Okay, and which is some headache for the processor. Okay, so it will consume some CPU time. In a meanwhile time, instead of that, CPU has executed some process. Okay, so in that manner our CPU time will be wasted by in order to copy process from one part of a memory to another part, in order to accumulate the total amount of free space at one place. Okay, so this is the concept of dynamic partitioning using the contiguous memory that contiguous method of dynamic partitioning. Okay, so in the next lecture I will be discussing a non-contiguous. Okay, and we have two methods, paging and segmentation. So it's a brief introduction about the memory management, and we have lot of concepts in this unit. Okay, memory management, we have overlays, we have concept of virtual memory, and then we have concept of multi-level paging and all. So that's all for now. Okay, thank you.